need to be able to work out the scale that's been used for each and every graph that you come across so that you can read off the values. If we look at this graph, we can see that it's going up in 50s for the big steps, but we need to work out what the little steps are so that we can work out more precisely the values of the particular data points on this graph. So the way that we do this is you start with the first one after the 0. So the first number after the 0 is 50. So we're going to use 50 and we're going to divide it by how many little divisions there are between the 0 and the 50. Take my word for it, or you can count it later for yourself, but there are 10. So to work out what each little one is worth, we're going to do 50 divided by 10, which gives us 5. And so each of those little divisions is worth 5 each. So if I was to look at this point here and want to work out what value that had, we can see it's just one little square above the 150 line. We know each of those little ones are worth 5. So that point is worth 155. Let's do another example. So same idea again. So the first number after the 0 on the scale is a 5. Again, fairly standard, but not always. So always do a quick double check. There are 10 little divisions. So we're going to divide by 10. And 5 divided by 10 gives us 0.5. So this time each of those little divisions is worth 0.5. If we pick this point here, 1, 2, 3 above the 10 mark, so we've got 3 0.5s, which would be 1.5. So that point would be worth 11.5. So now let's have a look at how we work out the scale for ourselves if we're going to actually draw it. So we need two pieces of information. We need the maximum value that we're going to have to plot on our graph, which in this case is the 24. And then the other thing that we need to know is how many big squares of space do we have to draw it in. So if we take a standard A4 size piece of graph paper, they have about 14 squares. So if we take the maximum and divide it by the number of squares, that gives us a rough idea of what our scale needs to be. So that's not easy to do in your head, so I'm going to bring up my calculator. So we're going to do 24 divided by 14 equals, decimal terms, 1.71 blah blah blah. Now clearly we're not going to use that figure as our scale. So when you use this process, you always round up, not down. If you round down, you'll end up not having enough space for everything that you want. If we were to round that down to 1, for example, we'd need 24 squares to represent the 24 for Friday. Whereas if we round up, so that's going to be 2 for a large square, then we can see that if we divide 24 by 2, we get 12. We're only actually going to need to use 12 squares worth to actually plot our graph, but that's fine. So let me now show you the plotted graph. And you can see we're going up in 2s for the big jumps, the big squares on this particular paper. So here we look for our maximum, and our maximum value here is this, and our number of squares again is 14 squares. So again, you could take the maximum, divide it by the 14 and get your idea. The other way you can approach this, if you don't have a calculator to hand anyway, is to round the maximum that you've got. So this one would nicely round to 1,400, and then it's a fairly easy jump to see that each large square would need to be worth 100 to get it to fit on here. Here's the graph going up in hundreds.